strain curve. For finding out the relationship between stress and strain for a material under tensile stress, we generally use a test cylinder and stretch it by applying a force. Changes in length are observed to measure the strain, which is then plotted with respect to the stress. Stress-strain curves differ with different materials used as the test cylinder. Graphs for compression and shear stress are analogous to those for tensile stress. Let us now study one such curve in detail. Between points 0 and A, the curve is a straight line. Hooke's law is obeyed in this region. This region is the region of elastic behavior. In this region, application of a force deforms the body, but removal of the force results in the body returning to its original form. Stress and strain are not proportional in the region AB, but the body still returns to its original position on removal of force within the region. The point B is known as the yield point. The stress at point B is known as the yield strength. Application of stress greater than the yield stress leads to a rapid increase in strain. This is shown in the region BD. In this region, the material ceases to exhibit elastic behavior and becomes plastic in nature. This means that the material cannot recover completely from the applied force and remains deformed. Thus, even though stress may be zero, strain is not zero. The material is then said to have a permanent set. The deformation in this case is known as plastic deformation. The point D is known as the ultimate tensile strength of the material. Beyond this point, applying even a lesser force will result in additional strain in the material. If the points C and D are close to each other, then the material is brittle in nature. If these 2 points are at a distance from each other, then the material is ductile. Materials like rubber can be stretched over long lengths and still manage to return to their original shape. These materials are characterized by a large elastic region, although the entire region may not obey Hooke's law. Such materials are known as elastomers.